Before you assemble the electronics into the robot chassis, you want to test each pin that connects the inputs and the outputs on your robot, because it may be difficult to reach certain parts of the printed circuit board once the battery pack and motors are screwed into place. The first thing you want to do is put the 4-pointed servo horns onto the servo drive shafts. Be very careful when you screw the small black screws in that you press inwards quite hard with a screwdriver. This will stop the star-pointed screwdriver tip from jumping in the head of the screw. If the screwdriver jumps or slips, that will strip the head of the screw and render it useless, and you may have to buy another servo motor for your robot. Here you can see a close-up of the Firetech continuous rotation servos. There are other makes of continuous rotation servos, but this type is quite powerful and fast, which is desirable in a competition robot. Before we build the robot chassis, it is a good idea to connect and test and calibrate your continuous rotation servos. To adjust the Firetech continuous rotation servo, you will notice if you shine the light on your cell phone into the adjuster hole that you're going to need a fine-tipped screwdriver. In a jeweler's screwdriver set, the 1.4mm flat tip screwdriver seems to work best. The tip of the screwdriver needs to be able to fit into the adjuster hole of the trim pot, but should not stick in the hole. You will need to use a bit of trial and error, but be careful, because if you force a large screwdriver into the hole, you may damage the adjustment trim pot to the extent that you might have to replace that continuous rotation servo. When you're ready, upload the continuous rotation servo calibration program to the microcontroller and switch on the motor power switch, and then very slowly and carefully adjust the trim pot to around the midpoint where the continuous rotation servo should slow down and then completely stop moving, not even vibrating or making buzzing noises. When you pull the screwdriver out, it is quite likely you will disturb the setting of the trim pot, which is quite sensitive. With some practice, you will learn how to remove the screwdriver without disturbing the setting. Simply repeat the procedure again and again until you have the continuous rotation servo trimmed and that it remains trimmed once you remove the screwdriver. When the servo is getting the calibrate signal with the motor power switch on, the motor should be stopped. And if you pull at the servo horn, it should feel like the brakes are on. When you switch the power off, the servo should be able to turn by pulling gently on the servo horn. Do not wind the servo motors hard by twisting on the servo horn, as you can strip the gears this way, and then you will have to throw the continuous rotation servo out and purchase another one. You can calibrate the servos once the robot is built with the motors screwed in place, but it is a good idea to test things before screwing everything together. Before you assemble the chassis, you may want to download and study a printout of what engineers refer to as an exploded view of the mechanical assembly, which you can see here in the video. To get started, find the packet of fasteners and look for the two 3mm screws with a countersunk head. They should be 12mm long. Countersunk head screws have a conical shape below the screwdriver slot. Place the countersunk head M3 screws into the battery holder, then screw a plastic nut onto the screw underneath the battery pack to act as a spacer between the battery holder and the circuit board. The reason why we put spacer nuts between the battery pack and the printed circuit board is because the wires sticking out of the bottom of the printed circuit board prevent the battery holder from resting flat on the printed circuit board, which means a spacer is required. The reason why we use plastic nuts as spacers is to prevent any possibility of a short circuit. Once the battery holder is mounted on the printed circuit board, place spring lock washers and then metal nuts onto the screws. Make sure you tighten the nuts up really well which is why you want to use metal nuts in this position, so the spring lock washers are squashed flat. Then the battery pack won't work loose somewhere down the line as you remove the batteries from the robot to recharge them. Notice how we use a screwdriver to hold the screws from turning as we tighten up the nuts. Here I'm showing how important it is that the wires for the battery pack lie flat in the grooves. If the wires do not lie flush in the grooves, they may get in the way of the white blocks that will be used to hold the chassis together. Good idea to test putting the batteries into the holder, then switch the Primo controller board on and see if there are any problems. Now remove the batteries from the robot because lithium batteries are very powerful and can pose a risk of fire if short-circuited. There are 4 different types of white blocks that could be supplied with your Arduino bot kit. They all fit perfectly because of the slotted holes in the chassis. In this demonstration video, the blocks are of the slightly bigger type, which means there's very little clearance between the blocks and the battery pack. That's why it's important to have the wires lying flat in the grooves. When you use a star-type screwdriver, always remember to hold a good quality screwdriver really firm and push it hard into the head of the screw so that it does not jump as you screw it in. If the screwdriver jumps as you turn it, it may strip the head of the screw. Tighten the screw until the white block is pulled firmly up against the red circuit board or chassis parts. Make sure the white blocks are lined up nice and straight. Before you attach the chassis side piece, make sure the battery wires are lined up in their grooves. Notice how, with this particular type of block, there's just enough space and everything fits together perfectly. You might have been supplied blocks that are slightly smaller, in which case you'll have a little bit of extra space around the blocks. If the tip of the screwdriver is too small and feels very loose, the screwdriver will strip the head of the screw, making it impossible to get in or out. Now temporarily place a servo motor in the chassis frame to check everything is correct. Once you've done this, screw on the rear chassis element that holds the roller ball at the back of the robot. The small extra printed circuit boards make up the line following module, which we will show you how to assemble in another video at youtube.com/electronicsafrica. You want to file off the sharp points carefully where the printed circuit boards were joined to each other. To prevent this video from becoming excessively long, we've used time-lapse photography for some of the sequences. If the video is moving along too quickly, simply pause while you follow along. We do recommend that you watch this video through at least twice, from end to end, before you tackle this job. Once the chassis is assembled, check that everything fits together nicely. Locate 8 12mm long or 16mm long M3 cheesehead screws, flat washers, 8 spring lock washers, and 8 flat nuts. Introduce the continuous rotation servo motors into the chassis of the robot from the outside, with the flange of the continuous rotation servos resting on the outside of the chassis. Also, the continuous rotation servo adjuster holes should be facing forward so they can be accessed for the next time you need to calibrate the motors when they will be in the chassis of the robot. What this effectively means is the servo motor wires should be coming out at the front of the robot. Place a flat washer onto each screw. Then insert the screw from the outside into the holes on the flange of the servo motors and then through the chassis. Then add a spring lock washer and a flat nut and tighten everything up. Do not completely tighten up the nuts and bolts holding the continuous rotation servos in place until they've all been fitted, or you might find it difficult to get some of the screws in. Once all the nuts and bolts are in place, tighten everything up so the spring lock washers are squashed flat. Then they won't come loose. But don't tighten everything up to the extent that the plastic flanges on the continuous rotation servo motor casings become damaged. A good quality pair of needle nose pliers and a decent screwdriver can make this job a lot easier because you have to reach into places that are quite tight. How to wire up the plug connector from the battery pack was covered in the video on how to build the circuit board at www.youtube.com/electronicsafrica. You can feed the wires through the extra slots on the printed circuit board before you solder the plug on, or you can simply use a Ziploc cable tie to act as strain relief, which will prevent the wires from bending and ultimately breaking loose. The large ball is used to balance the robot, as the robot only has 2 wheels. Good idea to fit the drive wheels onto the robot before you fit the ball. There is a video on how to make up the drive wheels at youtube.com/electronicsafrica. There is a 50mm long M3 cheesehead screw to mount the ball on the back of the robot. Use 2 Ziploc cable ties to secure the ball in place, making sure the robot is level. Pull the Ziploc cable ties tight with a pair of pliers and then clip off the excess length of plastic. Now you want to replace the batteries in the robot and download the program